Hi everyone, welcome back to Beyond Your Knowledge. Well, this is going to be an interesting topic as others. But today we are going to be speaking about the parietal cell acid secretion. So to understand this topic, we are going to be drawing some interesting things. Okay, now before we continue, I would like to tell you Isaiah 52:7, beautiful promise from the Lord. Okay, so and this one says that how beautiful upon the mountains and the feet of him who brings good news, who publishes peace, who brings good news of happiness, who publishes salvation, who says to Zion, your God reigns. And today tell you, if you would like to accept these words, your God reigns. Otherwise, just enjoy the video and yeah. So let's just see. So parietal cell acid secretion. Parietal cell acid secretion, it is important that we. So I'm going to be drawing some areas of the stomach. Okay. First, I would like to see the gastric lumen. Okay. So the gastric lumen, we're going to just do it this green here. Okay, and then let's just So here is going to be the gastric lumen. Okay, so this is the gastric lumen. Now, there we go. What we can find in the gastric lumen. In the gastric lumen, well, let me just write it here. Gastric lumen. Okay, so the other area that we are going to see, it is basically the cells and the vagus stimulation and everything. Okay, so let's just start to breaking down. So this secretion is going to happen as follows. So we have your vagus nerve. Okay, so this vagus nerve is going to go to those cells that I'm going to draw here. So this is a parietal cell. Okay, and then that says here. Okay, and then again the same. And then one more time. Then one more time. Okay, so this one is going to have different receptors. Okay, so we're going to have a receptor which is called M3 receptor. Let me just do them in black better. M3 receptor. Also, this cell is going to have another receptor which is called the CCKB receptors. Okay, so each of those cells have it. It's just CCKB receptors and H2 receptors. Okay, so we can just draw the receptors here. Okay, so just like this. Let's just do this one here. Okay, so those are the receptors. Now all of those is going to join one area and we will see soon. Okay, but let's just start with the vagus nerve. So what's going on? The vagus nerve go to so go to the M3 receptors, this one here, go to this one. So the M3, let me just do this better. We need the red. Okay, there we go. So the vagus nerve go here, and also go to here, which is go to the G cell. Okay, so here is a cell, it's called G cell. Now it goes to those two places. The vagus nerve can go to the G cell and can go to the M3 receptors directly. So when go to the M3 receptors, who is going to enter through the M3 receptors? It's going to be ACH. ACH, acetylcholine. Okay, so H should be not, yeah, there we go. ACH. Now, one time enter there to the M3 receptor inside of the cell, and now it needs to go to a pump to stimulate a pump that we have right here. Okay, so we have this pump here. Okay, so now let's just, there we go. So this pump is called the Atpase pump. Now, this pump has something interesting, because from this pump is Atpase pump, potassium and hydrogen. Okay, and hydrogen. Got it? Now, let's just continue here. You receive the stimulation by the vagus nerve, go with the acetylcholine, go to the M3 receptors, we are here, and then this M3 receptors is going to stimulate, so we're going to put those sign of, it's going to stimulate the ATPase, hydrogen potassium ATPase pump. Now, for now we are fine, and this one here is the parietal cells. All this is the parietal cells. Okay, so this is the parietal cells, all those, and this is the gastric lumen that we mentioned before. Okay, okay, let's see what else vagus nerve is going to do. Now, vagus nerve going to stimulate the G cells right here, but who is going to go through is going to be GRP positive. Probably we should mention what does GRP stand for. So GRP stands for gastrin, G for gastrin, R for releasing, and P for peptide. Got it? Yeah. Well, let's just move on. So vagus nerve is going to stimulate the gastrin releasing peptide, GRP positive, to the G cells, and then the G cells is going to be is going to go here, and this is gastrin. Okay, and also this one go to another cell. Look at this, go to another cells here, and this cell is called Ecl cell. Ecl cell. Okay, we will come back to this Ecl cell, but just keep it in mind there for now. Okay, so we will come back to that one. Let's just continue what's going to happen with gastrin. So gastrin, so go through the receptors here. Now it's going to cross through the CCKB receptors, and is going to join this group here to what? To stimulate your to stimulate your hydrogen potassium, this pump, hydrogen potassium ATPase. Okay, so basically we have two that is going to stimulate this one. First, acetylcholine that entered through the M receptors. Second, gastrin that entered through the CCKB receptors. Now, we're going to talk one more that we already talked, we started, but we continue. It's called the Ecl cell. So Ecl stands for enterochromaffin. Okay, I think that probably we don't have too much room there. Let me just do better on the top. Okay, so let's just do it here. So just follow what I'm writing. So Ecl stands for enterochromaffin. Like cells. Okay, now these G cells go to the Ecls beside to the, so go now there, first stimulate G cells to gastric, now go to the Ecl cells, but the Ecl cell is going to send something is called histamine. This histamine is going to cross which receptor? Yes, you're right, H2 receptors. And now one time you cross, so what do you think it's going to do? Yes, it's going to stimulate, there we go, it's going to stimulate your hydrogen potassium ATPase pump. Okay, and one more thing, so that is working. So we have three things: M3 receptor, CCK receptor, H2 receptors. Each of those receptors receive something. M3 acetylcholine, CCK gastrin, and H2 receptor histamine. Now in the parietal cell, there is another electrolyte that is going to come from the parietal cells to the gastric lumen, and this one is chloride. So chloride just come here, okay, so freely cross. Okay, now I think with that we can move on to present some drugs that can block some of those receptors. So we can start with the ATPase. Who do you think that can block your ATPase, hydrogen potassium ATPase pump, to avoid that the secretions become high of acid? Well, the one that is going to inhibit that one is called omeprazole. So omeprazole is one of those examples of the proton pump inhibitors. Okay, proton pump for hydrogen potassium pump inhibitors. So this one, it is blocked by the PPI, proton pump inhibitors, and example of the PPI is omeprazole. Okay, now probably, yeah, let's see something. Yeah, I was thinking just to change the color of these cells, so instead of red, orange or something, but well, so I think that probably is fine, so we can do it, but yeah, that's okay. So let's just omeprazole, where we already know omeprazole is going to block the hydrogen potassium ATPase pump, and also the other drug that we're going to mention here that is going to block the H2 receptors, so which is the drug that is going to work and it's going to avoid the histamine enter, and this drug is histamine. Right? Yeah, so just quick more points. Yeah, I just changed the color to orange, but that's okay. Well, yeah, so gastrin. So gastrin also responds to protein-rich meals. Okay, so this is another point that I just would like to mention. And also, if we're giving to the patient any of those, or any antihistamine, so for example cimetidine, okay, or if we're giving to the patient omeprazole or PPI, so basically which one do you think that is going to block all those three stimulation that happen? So, and I'm just correcting here because I wrote histamine twice and it's cemented in an example that was given. Yeah. Now, yeah, so do you think that is going to be cimetidine or another family from the H2 blockers that is going to block the three processes of the acetylcholine, gastrin, and histamine? Well, probably the answer is no, because this work directly into the H2 receptors. So the one that is going to block all those three that avoid the stimulation of the proton pumps, proton pumps or hydrogen potassium ATPase inhibitors, omeprazole, which is a proton pumps inhibitors. Okay, so basically one time you block there, so you block everything. So yeah, which is important to keep in mind those details or those points. So so I think that basically we are done with this one, and hopefully we learn something. And remember that we can do all things through Christ who strengthens us. And yeah, so God bless you, and we will see you